Okay. Uh, Hello everyone. Another session, module 12, wireless LAN concepts. I have to say, probably one of the most interesting modules that I had, most requested as well. So what will we be looking at today? The module objective is to explain how wireless LANs enable network connectivity, and we'll be looking to describe the wireless LAN technologies and standards, describe its components, its infrastructure, explain how the technology enables its operation, explain how controllers uses the CAPWAP to manage multiple access points. We also look to describe channel management, describe the threats in wireless LANs, and lastly, look at measures we can take to secure the wireless LAN network against those threats. Right. So quickly to the introduction. A wireless LAN is a type of a wireless network that is commonly used in homes, offices, campuses. It makes mobility possible within the home and business environments. Wireless infrastructure adapts rapidly to changing needs of technologies. Right. So with the first slide, we have basically a definition, not so much a definition, but by definition, a wireless local area network is just a network that allows devices to connect each other or to connect to the internet without the need of physical cables. So with wireless lines, we don't have physical cables connecting devices. We all know of Wi-Fi. With Wi-Fi, you just connect to your access point wirelessly. And that is the basic definition of wireless line. And it comes with a number of benefits. All right, let me see. It comes with a number of benefits. All right, I'm going to speak of mainly probably three or four. Number one being benefit of mobility. So with wireless networks, you have the freedom to move. You are not constricted to being in one position where you have your wired network. With wireless, you have that freedom to move because you're connected wirelessly to an access point. So that is one benefit of wireless networks. Number two, we can talk of scalability. So as a benefit, it's much easier to scale a wireless network. How? I'll give an example. If you have an access point, it means you can extend your network just using the access point. So you connect your access point to the wired network, and with that access point, you can easily get more clients, therefore scaling your network. So if you want to improve coverage, you just add another access point, then you can easily scale your network that way. With wired though, you will need to have all the physical cabling, which makes scalability possible, yes, but a bit more difficult. It's much easier to scale with wireless networks. All right, let's talk of in terms of cost as well. From what I just explained, if you require more physical cabling, if you want to scale, it means that is more cost. In terms of installation as well, physical cabling, more time consuming, labor, you actually have to work. With wireless, you can just add an access point, some configurations, and you can have multiple devices connecting to the network. That's not the same thing with a wired network. You need to configure physical cabling to each and every device. So in terms of cost and effectiveness, definitely wireless networks are more cost effective. Right. Lastly, productivity. In terms of productivity, I think wireless networks greatly improve productivity in the sense you can work from everywhere. So in an office, you are not concentrated working in your office. You can go to another office using your same device and work from there. You can go change, move to another branch, still be connected to the network. So in terms of productivity, it offers improved productivity, obviously better than the wired network. So you can see wireless networks, they come with great benefits, a lot of risks as well, but great benefits. All right, types of wireless networks. So we have four type of networks there described: the wireless personal area network, we have the wireless LAN, we have the wireless MAN, and we have the wireless WAN. All right, the wireless PAN, this is low power and short range. Let me move this. This is low power and short range, 6 to 9 meters, based on the 802.15 standard and 2.4 gigahertz frequency. Bluetooth and Zigbee are wireless PAN examples. Right. As we go through this module, take note of the standards. It's very important to know these IEEE standards. Which specific standards defines Bluetooth, for example? What standard defines Wi-Fi? What standard defines WiMAX? What is the frequency being used? We obviously get to know what is a standard. If you didn't know what a standard is, we introduced it probably module number 3, CCNA1, standards, right? And we introduced the IEEE standard. Here, it's now very important to know all the standards that we are going to be using, starting with the Bluetooth. The standard for Bluetooth, 802.15.1. That's Bluetooth for you. Then we have Zigbee, 802.15.4, IEEE. So you need to know all the standards. We'll get through all of them. I just had to highlight going through this module best to know what are the standards that we have and what are the frequencies that are used by those standards. What are the frequencies that are defined by those standards? So with wireless PAN, we have these two, the Bluetooth and the Zigbee, short range. We have the wireless LAN, medium-sized networks, up to 300 feet, based on IEEE 802.11 standard. So with wireless LAN, that is where our Wi-Fi is. With wireless LAN, our Wi-Fi is right here. It is defined by the 802.11 standard. So as you go, you see we have 802.11 A, B, AC, AX, N, G, etc., etc. All standards of the wireless LANs, right? And you see they use two frequencies, the 2.4 and the 5 gigahertz frequency, right? Looking at wireless MANs, large geographic areas such as city or a district uses specific licensed frequencies. So an example for here with wireless MANs, we can look at WiMAX. That is an example, which is IEEE, I think 802.16, WiMAX. So it covers a larger area. I think probably in all the classes that I've taught, we have a number of students who are using WiMAX. You can see by the towers with those round things like this. Their antennas, they are round like this. And you can get your Wi-Fi, you can get your wireless access through those antennas. Right, that is WiMAX. We have wireless WANs, extensive geographic area for national global communication, uses specific licensed frequencies. Right, for our wireless WANs, so this is where we have our cellular technologies here. So this is where we have our 3Gs, our 4G LTE, and now our 5G. So you can see as we go from the wireless PAN to the wireless WAN, you can see the coverage, the geographical area, it obviously increases. All of them, they are wireless networks, but their definitions are different with the frequencies they use, with the coverage they have, etc., etc. So these are the types of wireless networks that we have, right? Wireless technologies. All right. So we are going to look at specifically these two technologies in this slide, the Bluetooth and the WiMAX. The Bluetooth and IEEE wireless PAN standard used for device pairing at up to 100-meter distances. We all know of Bluetooth. Bluetooth, it has two main types, right? We have what we call the BLE, the Bluetooth Low Energy, which supports mesh topology to large-scale network devices. Basically, BLE, if you have used IoT devices, this is the kind of Bluetooth that it uses. Why? Because it is designed for low power devices, focusing mostly on battery life conservation, right? So all your IoT devices, if they're using Bluetooth, they're using this type of Bluetooth, BLE, right? So examples of application, if you have smart home devices that we want to use, the fitness trackers that you use, they use BLE because it uses low power. All right. So the other type, we have the Bluetooth basic rate, enhanced data rate, BR/EDR, which supports point-to-point topologies and is optimized for audio streaming. Now with the second one, this is the OG version of Bluetooth. This is the one you see on your phones, designed for transferring voice, data over very short distances. Examples of application, you have your wireless headsets. You transfer audio from your phone to your wireless headsets. It uses BR/EDR. You have another example. When you want to transfer files, probably we no longer use Bluetooth that much to transfer files these days. But the ones that we used, it was the BR/EDR. So there are two different types of Bluetooth and two different optimizations of each type. WiMAX, worldwide interoperability for microwave access. This is an alternative broadband wired internet connections, IEEE 802.16, up to 50 kilometers, which supports up to 50 kilometers. So basically, these are the towers that I was talking of, these ones. So if you see, pese panoiswa towers, even on a network, you can see some of these towers, a microwave access. So you can get wireless internet via those towers. You just need your antenna and you'll be communicating using those antennas. Right. Continuing, cellular broadband carries both voice and data used by phones, automobile, tablets, laptops. We have GSM, CDMA. So basically, I think that defines the 2G, probably the 3G as well. 2G and 3G only. So cellular broadband, I already talked of the cellular technologies that we know, and Econet, our net ones, the 3Gs, 4G, 5G. Here they just stopped at 2G, 3G. Okay. So we also have the satellite broadbands. It's another wireless technology. Your Elon Musk's Starlink uses directional satellite dish aligned with satellite in a geostationary orbit. Need for clear line of sight, typically used in rural locations. The whole of Zimbabwe, probably a rural location. Everyone wants to use the Starlink. Right. 802.11 standards. Very important to understand what these standards are. Right. So just a brief background. Let's talk of 802.x. All the standards which begins with 802. These are collections of our local area networks to our metropolitans, to our wireless area networks. We have also our, let me remove this. We have also our personal area networks. So this is just a collection of all our networks, everything that starts with 802.x, x representing any number or a letter after that. Right. With the most notable examples, if you know of Ethernet, 802.3, that is IEEE 802.3, that is Ethernet for you. We have already discussed 802.1, which is our wireless LAN. We have 802.15, which is our wireless PAN. Those, I think, are the best examples that we can have. Right? With the 802.11, you see what these standards define. They define the frequency bands. You need to take note of this. They define the frequency bands that are used. They define the data rates for every standard. They also define the modulation techniques, which we will not dwell on in this module. They also define the antenna technology that is used, the security protocols that is used. So for every standard that you have different definitions from the frequency bands, data rates, modulation techniques, antenna tech, and security protocols. With 802.11, you can see we started in 99 up to 2021. We have a new standard which started in 2021. I think that is Wi-Fi, if you've heard of Wi-Fi 6. All right, 1997, the original, the OG 802.11. You can see the data rates, 2 megabytes per second. With this one, I'm not sure the latest, what are the data rates, but you can see with this one, we have up to 1.3 gigabytes per second. So the data rates obviously increasing with increasing standards with respect to the year they were developed. 802.11a data rates 54 megabytes, 600 at 802.11n. Different standards, different frequencies, different data rates. Probably it's much easier to focus on the data rates so that you can choose which type of standard that you want to use. So my standards, if you look at my standards, Ayaruka, my legacy standards, compatibility, very difficult. They are not easily compatible with, let's say you want to use an access point. Access point, the latest to access points that we have, probably won't support devices which have these standards. Right? So compatibility is a bit difficult, but with the newer standards, all is well. Another point to note, the radio frequency, the frequencies which are being used. Point to note these two, 802.11 and 802.11ax. 802.11n, 802.11ax, which uses both. It uses both the 2.4 and the 5 gigahertz frequency. Every other standard, it has one frequency that it uses. All right. Maybe you might ask the question, 2.4 gigahertz, what is that? What is the frequency? 5 gigahertz, what is that? So this is a frequency which is used to broadcast your signals. In Wi-Fi, the 2.4 gigahertz frequency is used to broadcast, all of the 5 gigahertz is used to broadcast your signals. So the frequency that they use, 2.4 and 5 gigahertz simultaneously. All wireless devices, they operate in the range of the electromagnetic spectrum. Wireless LAN networks operate in 2.4 gigahertz and 5 gigahertz frequency bands. Ultra high frequency, 2.4. What is S? Super high frequency, I think, 5 gigahertz. And you can see the different standards which operate at 2.4 and 5 gigahertz simultaneously. All right, let's look at 2.4 and 5 gigahertz. 2.4 gigahertz. Let's look at those frequencies. Why do we have those two different frequencies? And how do we compare them? What is the difference between them? The difference in general, we can compare those two using the speed, which is the data rates. We can compare them using the range, penetration as well. We can compare them using, let's say, congestion. And lastly, in terms of applications. All right, let's compare the 2.4 gigahertz and the 5 gigahertz frequencies using speed, range, congestion, and application. In terms of speed, The 5 gigahertz has more speed. In terms of speed, the 5 gigahertz has more speed, therefore more data rates. In terms of range, you see these ones, they don't travel that further. If you have obstructions, if you have buildings, they won't be able to go past the buildings. This one, uh, no, how do I put this? No wall penetration, right? These ones travel over very small distances because of the high frequencies, right? The 2.4 gigahertz, they can travel, penetrate the wall. So in a place where you have obstructions, it's better that you use 2.4 gigahertz because that frequency to be able to it is able to penetrate some of those walls. In terms of application, you can see from the comparisons that we are having, they have different applications because of their characteristics. That one, wall penetration. The other one, obviously, the data rates. In terms of congestion, you see many devices, they use the 2.4 gigahertz frequency. Many devices, they use the 2.4 gigahertz frequency range. Therefore, congestion is more here. Congestion is more with the 2.4 gigahertz because a lot of devices, your fluorescent lights, they have 2.4, your microwaves, they have 2.4, probably your TV, some of your TVs, they use the 2.4 frequency. Your Bluetooth, it uses 2.4. Therefore, that frequency band is congested. So if you wanted to use a frequency band which is less congested, it's definitely the 5 gigahertz. In terms of applications, you see here with the 2.4, your smart devices, if you want to connect your smart devices in your home, your IoT devices, it's much better to use the 2.4 gigahertz because of its range, because you don't need much data rates for 2.4 gigahertz. You don't need that much speed when you're connecting your smart IoT devices. In contrast, in comparison, when you are streaming, when you are gaming, you need the speed. So therefore, you use the 5 gigahertz frequency. If you use the 2.4, you probably not be able to stream or to do your gaming for those who do gaming. So if your AP, it has 2.4, both it offers 2.4 gigahertz and 5, if the standard, your APS, it offers these two. It means you can separate. If you want to connect your smart devices, you can use that one. If you want to do your streaming, you can use that frequency. I think that's another advantage of having the standard like N, which uses both frequencies 2.4 and 5 gigahertz. Right. Wireless standard organizations. Standards ensure interoperability between devices made by different manufacturers. Internationally, we have 3 organizations influencing the wireless LAN standards. The ITU, which regulates allocation of radio spectrum. The IEEE, which specifies the radio frequency, how a radio frequency is modulated to carry information. We have the Wi-Fi Alliance, which promotes the growth and acceptance of wireless LANs. So we have those 3 organizations which basically help in ensuring interoperability between devices from different vendors. Right, not much there. Wireless components. Where are we? Wireless components, wireless LAN components. Right. For us to communicate wirelessly, we have a couple of components which we are going to define, which will help us in communicating wirelessly. Number 1, we have the NIC. The NIC, to communicate wirelessly, laptops, smartphones, latest automobiles include integrated wireless NICs that incorporate a radio transmitter and receiver. If a device does not have an integrated wireless NIC, then a USB wireless adapter can be used. The NIC, network interface card, is the network interface card. What is that? It's just a hardware component. It's just a hardware component. It might be integrated to your devices, or if it's not integrated, you have something like this, a USB. It's external. You connect your USB, then your device has an NIC. Sometimes it's integrated to the PC. Your laptops, most of the laptops, they have the NIC integrated. You can connect directly without ending any modules, connect to the Wi-Fi, connect to the wireless network, right? It's a hardware component that allows devices to connect to a wireless network. And it has both the transmitter, a radio transmitter, and a radio receiver. That's the NIC for you. Then we have the home router. A home user typically interconnects wireless devices using a wireless router. Wireless router serves as the following: an access point, switch, and a router. So with the wireless router, tichapinda deep patienda configurations, but you see with the wireless router, it serves three purposes, which can be served by three different devices, as you will see. An access point can be a different device to a switch and to a router. Those are three different devices. But with your wireless home router, in a very small network, a home network, which is very small, you can use a wireless router, which combines all those three. It can act as an access point, as a switch, and as a router. It provides wireless access, it interconnects wired devices, and it provides your default gateway to the internet. So a wireless router is just a device which can act as those three things that are highlighted. Our access point, right? Wireless clients use their wireless NIC to discover nearby access points. Clients then attempt to associate and authenticate with an AP. After authentication, wireless users have access to network resources. So an access point, basically what it does, it provides access to the clients wirelessly. So an access point, you can have your wired network. We have two things. Let me define what we call a wired network. A wired network is so far this thing that we know here. Let's have a router. This is our wired network. This is our PC 1. That PC is connected to the wired network, connected to the switch, connected to the router. A router connects to the internet. That is a wired network. If I want to connect a wireless client to that network, what I need to have is an access point, an AP, which broadcasts a wireless, which broadcasts its SSID. Then we go through the process of authentication. Then we have probably our PC. Okay, let's say our phone, our smartphone, not our PC, or our laptop, which connects wirelessly to the AP, from the AP to the wired network. So two networks that I've defined there, the wired network and the wireless network. And what is in between those two is the access point. So the access point connects your wireless network to the wired network. Very important. Right. AP categories. An access point can be categorized as either autonomous or controller-based. With autonomous APs, these are standalone devices configured through the GUI. Each autonomous AP acts independently of the others and is configured and managed manually by the administrator. With the controller-based, these are also known as the lightweight APs. And it uses the lightweight access point protocol to communicate with a controller. All right. In simple terms, excuse me, in simple terms, the AAP, let's call this one the AAP, the autonomous AAP, let's call this one the lightweight AAP. So the AAP functions independently of the wireless LAN controller. We'll define the WLC later on, which this is sort of the central point, which manages other access points. With the AAP, it acts and functions independently. It's a standalone device. With the LAP, the lightweight access point, it is controlled by the wireless LAN controller, the WLC, AOC. So that is the main difference between those two. If you buy an AP, very important to highlight as well, if you buy an AP, the software in your AP determines if it's an autonomous AP or a lightweight AP. So you can just change the configurations, and an AP can either be an AAP or an LAP. It's just a bit of a change in the software. And we have those two types. All right. Anything important? The WLC is used as a central point of management for multiple APs. Right. Let's look at those diagrams. This is a diagram for AAP. This is our access point. The administrator configures this manually, and it acts independently of anything. All right. And you get access, these wireless clients get access via the AP. With this one, the lightweight access point, this is our lightweight access point. It gets its configuration, even authentication, association of these clients to the network. It first goes through to the WLC. Then authentication comes back. If you want to communicate, in terms of communication, you see the path that the traffic takes. It goes from your phone to the AP, to the WLC, then to the wired network. Two different paths. With this first one, we have from our client to the AP directly to the wired network, which is called the DS, the distribution system. We'll get to define the DS later on. So two different paths, very important to know. It will help when we do our configurations, understanding the different paths that traffic takes between the AAP and the LAP. So with this one, from here to the access point, it goes to the controller, then from the controller, it goes to the DS. So two different paths determined there. So the WLC controls multiple access points. This one, the first one, the AAP, if you have a small network, you don't have a lot of APs that you want to configure, you can use that first one, right? Just a minute. Right. So I was saying with AAPs, if you have a very small network, you're going to use two access points. Two access points will cover the whole network that you have. It's very easy. I can manually configure two standalone access points. My network functions perfectly. But in huge organizations, huge companies, let's say they have 50 access points, it's very difficult to go. It's not difficult, but it's time consuming, labor, configuring one access point after the other. So instead of configuring all the 50, 100 access points, you have the WLC, which is the central point where all the configurations of all the access points is done. So instead of configuring one after the other, we just go to the controller and we configure all the access points in the network. So two different type of access points which are used depending with application where you want to use them, AAP and LAP. Right. Wireless antennas, types of external antennas. External, keyword external. Your laptops, your phones, they don't have external antennas. It does not mean they don't have antennas. Your devices that you use to communicate wirelessly, they do have antennas, but some of them, most that we interact with on a day-to-day basis, they have internal antennas. But at times, if you are in business, there are times where you require external antennas, and it makes for better signal coverage, etc., etc. Types of external antennas that we have: omnidirectional, directional, multiple input, multiple output. That's MIMO. Omnidirectional provides 360-degree coverage. So this is the omni 360-degree coverage. It comes with a number of disadvantages as compared to directional, which focuses. This is directional right there. Directional antenna. Now this is telecommunications. This is no longer networking. This is telecom. We have directional antenna, which focuses the radio signal in a specific direction. So this is directional. Examples: Yagi parabolic dish, your satellite dish. MIMO, it uses multiple antennas to increase bandwidth. So instead of having one antenna, you have probably 4, 8, 12, 16 antennas, which greatly improves your bandwidth because you have multiple antennas, you have multiple data streams. Therefore, you can, in layman terms, you can send more data that way. Right, types of wireless antennas. Wireless LAN operation. Right, I can see 1 minute left. Let me stop this first part. We continue with the second part, starting with wireless LAN operations.